from Dubai, and thanks to all attendees to join in during the Ramadan time. Today's topic that we prepared will be fantastic. It resonates incredibly in the past weeks and months throughout the whole market. Stop the rework loop. Not all the projects that you're doing are super complex. Uh, the opposite is true. Many projects are repeated or similar or same kind of type, whether that's PEB type of structures, steel halls for manufacturing purposes, for warehouse processes, um, purposes, data centers, very popular lately. So all these can be uh, reworked or reused in case you know how to do it and you have the proper tools and data workflows. So this is exactly the topic that we will be discussing today, and we will give you 5 specific steps how you can stop the rework loop and utilize the past work in your future. We have quite a crowd today, 4 speakers. We have Venkatesh from GSD Idea. Hello, Venkatesh.
Hello, Jan. How are you?
Good. Audible, perfect. Okay. Talking to our team. Rose, can you hear us? Are you with us?
Hello, Ian. Hello, everyone.
Perfect. We have a guest speaker, Dominic Boric from Idea Statica. Hello, Dominic.
Hello, Jan. Hello to everybody in the audience. It's fantastic to be here with you in Dubai and working on this webinar.
Awesome. Perfect. Thank you, Dominic. Happy to have you. And myself, Jan Barta, Managing Director. As always, for the past year, we're using Demio platform that we like as it allows us to be interactive. There is a video. Okay, now it's on. So if you have a question, feel free to put it into the chat panel anytime throughout the session. We will be running 2 polls, so we will notify you. You will find the post next to the chat tab on the right-hand corner. And what is the specific agenda for today? We will be describing the problem. So what is the biggest issue contractors and EPC companies face nowadays? We'll be looking into the solution throughout the whole workflow, not just the connection design part, but really the whole end-to-end workflow. Then we will also look how it can be, how it looks like in the actual application of Idea Statica in the process, few tips and tricks, and Q&A in the end. Before we jump into the topic, just a quick reminder of how Idea Statica helps structural engineers, no matter whether you are a concrete steel contractor, EPC, precasting company, consultant. These use cases are the biggest pain of structural engineers for a long time, and these are the ones that Idea Statica supports and make your life easy with. Complex connections, no need to do further introduction. Everybody understands this is flagship of Idea Statica, flagship use case. Everyday connection compared to your most likely typical workflow with Excel spreadsheets, with a simplified tools, you can save up to 80% of the time using Idea Statica on the standard connections. Anchoring, another use case where engineers burn a lot of time. So whenever you need to check the base plate and consider the concrete block and reinforce it, this is where Idea Statica comes in and save time. The 4th use case, concrete discontinuities, beams, walls with openings, pier caps, pile caps. These are nightmare to design. and code check properly, especially if you need to do not just the ULS checks, but also the SLS checks. And the last use case is for coming back to steel, stability and buckling issues of a member, something what typically your global analysis tool will not provide. Okay, so that'd be the introduction. And now back to the topic of today. Dominic, please let us know
why we're
why.
speaking. All right, Jan, thank you. Let me just share my screen. All good? All good? Can you see my screen? All right, awesome, thank you. So what is the problem? Let's look at together at the connection design and to admit to ourselves that it doesn't fail in the calculations, it fails in the repetition. And let's start at viewing the contractors loop of connection design on the right, where we see individual steps coming from model updates, followed by force extractions, grouping, redesign, and reporting, and comments and rework from the consultants. And finally, ultimately resulting that this whole loop repeating again. None of these steps alone is particularly difficult. The problem lies in the frequency and the scale. When you have hundreds of similar joints, every loop becomes expensive. If we look at the bullet points on the left, the similar connection families appear repeatedly across multiple packages. That indicates duplication of design effort and discrepancies in the design resulting at the job site. Then identifying and grouping similar joints is a major time sink, and before any designing time of the connections can actually start. Designing capacity is limited. We all know that there is not enough of engineers in any office, and senior engineers are becoming the primary bottleneck because everybody is dependent on them. Excel and manual tracking doesn't scale. Excel-based and manual tracking makes traceability nearly impossible. It becomes very difficult to identify what changed, where it changed, and why, sustainably alongside the whole life of the project. Then we have the approval process of the consultants or the authorities. When such comments or disapproval appears, this drives the whole redesign cycle again. And last but not least, the late stage changes are viewed as normal in the industry. There could be a revision to loads, to member sizes, geometry, initiated by a new technology introduced in the project, or just some modifications driven by the investor or the client. This again further spins the repetition loop of redesign. Which brings me to the next slide, and that is where in this situation described in the contractor loops, what are the particular things that create the problem? It's the inconsistent assumptions across engineers and work packages that lead to variations in the redesign, where similar joints are very often engineered differently across multiple packages. That is not very economical, it's not effective. Then rework is required every revision cycle, meaning that the process restarts from the initial steps. Previously completed work is discarded and the entire process is repeated, which is extremely frustrating and results in a significant waste of engineers' time. Another issue is the dependency on individual engineers, as I already mentioned. This leads to knowledge silos. Only a limited number of engineers are familiar with with the Excel spreadsheets, the MathCut files that contain the calculations code and standard assumptions. As a result, this knowledge is not broadly shared across the team, but only kept within the individuals, and creates huge bottlenecks. Traceability gaps, then, another point, that arise as excessive time spent on manual administration, where errors are easily introduced. Working with IDs from the global model and then manually creating separate IDs for joint-related connections further compounds the problem, making it increasingly difficult, if not impossible, to accurately track changes over time. Last, but definitely not least, is reporting, and that becomes a major bottleneck. Manual and repetitive processes for creating and extracting reports for dozens or maybe even hundreds of connections into binder consume excessive amount of time of engineers, and that is just, again, contributes to the problem. Let's look at what scaling connection design actually means. Like, when we want to scale the connection design effectively, we need to tackle the standardization, establish repeatable connection logic, consistent modeling assumptions, and uniform workflows across all packages. Similar connections should be designed in the same way, regardless of who works on them or where they appear. Follow with the batch processing. Automatically group the joints, evaluate critical governing load effects, and run repeated checks in batches. Another point related to the problem is the traceability. Ensure the visibility into what changed, where it changed, and what is affected. Changes must be easy to identify, track, and they are audited throughout the whole design lifecycle. Another point is the approval-ready outputs. Generate standardized approval-ready reports at scale should not be a problem. Since reporting is repeated for large groups of connections, this is a huge opportunity to automate and to reduce the manual efforts. Then the revision resilience. It enables seamless re-import of updated models, meaning we reuse the existing designs, continue from the current workflow state, and only recheck what has been changed rather than restarting the whole process again. And last, engineering focus. We prioritize the unique or critical joints early in the process, and then avoid spending the time on low-risk repetitive connections, which are easier to tackle. We identify the critical joints early that require engineering judgment, and this increases the team throughput and significantly reduces the manual sorting and rework. Okay, now, before we get to that solution and we hear from Rose how to actually do that, I would like to know from our audience, where do you lose the most time in your current design check workflow? So I would like to launch the poll. And what are the options? We can vote for grouping and sorting similar joints across the model. Or is it either identifying the governing load combinations among many cases, or redesigning and checking after revisions, or preparing reports and submission binders for review that take a lot of time, or tracking and tracing the connections, IDs, and kind of knowing which joint is where. Let us know in your voting. And if it's something completely different, please submit your commentary to let us know what is your case. Okay, I'll give you a little more time to vote. All right. Thank you for voting. And we see that most of you have voted for grouping and sorting similar joints and followed with redesigning after revisions. I think we're very confident to tell you that we are able to help you with this, and how we actually do that we will be told by Rose. Rose, can you take the word?
Thank you so much, Dominic. Thank you so much for walking us through the problem. Let me just share my screen. I hope my screen is visible. Thank you for confirming, Venki. So now that we have looked at the contractor reality, which is the repeated connections, revision cycles, bottlenecks, reporting pressure, etc., the question is, how do you scale without scaling the headcount? Okay, obviously the answer is not working faster, but instead I would suggest something else, because it is 2026 and it's definitely changing the workflow. With the workflow, I'd like to introduce or to give you an overview about Idea Statica Checkboard. I would rather look at this as a design journey, more of a design journey where Checkboard is the connection designer. Starting from the global FEA model software, which is ETAP, STAT, SAP, Robot, whichever tool you use. And we import that global model directly into Idea Statica Checkboard. And this is where exactly Checkboard becomes the central hub. Now, let us see one by one what are the tasks that Checkboard as a connection designer do. The first one is auto grouping of connections. Yes, you obviously heard me right. Checkboard automatically detects all the joints in the model and groups similar connections together. So instead of manually sorting 200 to 800 joints into families, that pressure completely disappears. You immediately see what is repeated and what is unique. The second task of Checkboard would be to calculate the load extremes. It automatically calculates the governing load extremes for each of the groups and for individual connections as well. So instead of checking everything, every uh, detail of the connection, we check what actually matters. The third part, this is the scale moment that Dominic explained. You design one reference connection for the group, and then with one click, you run the batch analysis for all similar joints. So no copy paste, no rebuilding models, no repeating the same setup. Now, if you'd want to edit, edit once, rerun it, and then update the whole group. That's how you do it in Checkboard. And after the analysis, the greatest struggle of the designer is to generate the report. But in Checkboard, once everything is checked, we generate reports in bulk. And if there is a revision, update and then regenerate it again. And finally, the transfer of the design intent. As you can see, or as you might have heard, it just doesn't produce a PDF, but instead it would also transfer the content and 3D information and also the BIM and detailing to various departments. And the best part of all of this, the reason why I called Checkboard the central hub in the first place, is that inside the Checkboard, you will get to know what is done, what is pending, and what has failed, all in one place. So there is no person who will have to keep a tab on the entire design workflow, but instead a Checkboard does that for you. Now, let us elaborate the process and see a bit of Checkboard in detail, starting from the global FEA. There are 45 plus FAIR applications that can be linked with Idea Static at the moment. And if you go to the Idea Statica Support Center under BIM Workflow, supported integrations, you will be able to find the list of CAD FAIR softwares that can be integrated with Idea Statica, along with the demonstration of the integration process as well. So if your FEA software matches with any of that within the list, just click on it and then you can see the entire process by yourself. Now, once the import from FEA to checkboard is successful, let's see what exactly it imports and most importantly, how that import helps the designer. Coming to the properties or the imported data, it would primarily import the geometry and topology, which is the nodes and the members, the sections and profiles, which would be the steel cross section, and also the materials, the grades, and the basic properties, load cases, combinations and cases, internal forces, axial shear, moment, and the torsion forces, member directions, and also the rotations and offsets. And what does it do immediately? It immediately uh, identifies or auto identifies the connection locations in that model and groups them accordingly. So the primary task of the checkboard, as we've just discussed, is to auto group the connection across the whole model. Uh, so we can generate this connection groups by four methods, which would be first, which is none, very self-explanatory. If you want to connections to be grouped under no group, then you can select none. The second grouping is by typology. The third is the advanced with typology and cross section. And fourth, which would be the custom defined groups or user group. That is what's commonly called it as. Uh, Basically, it means that if you want to create a connection in a separate group and merge more connections to it, you can add those connections in a separate group. And also you can sort the connections by name, node, and also the status of the analysis. Now let's see what exactly typology and arrangement mean. So I've told you about typology and uh, the grouping part, but what exactly typology mean? Typology means the number of members, that is member count, and also the relative orientation of the member, whether it's a beam to column member, if it's a beam to beam connection, etc. And what is a subcategory of typology, which is the arrangement, that would be within a topology, which is grouped by cross sections and also the sizes of the cross section. So that's the base of the grouping in Idea Statica. Now the next task is the load combination. So let's just talk about the real load combinations. All right. So in real projects, we don't have five load combinations. We have hundreds and we have thousands. So the problem is knowing which one actually govern that particular connection. And checkboard automatically detects the governing maximum and minimum load effects for each of the connection group. So it looks at all combinations and reduces them into the small set that actually controls that particular design. Also, different checks are governed differently, very differently. So axial force might govern one combination, shear and bending another. Interaction is a whole different story. So uh, we would take a longer time to understand or create that loop, but checkboard handles that logic very automatically. Now the question is that what is the logic that runs behind the selection of governing load cases? It's obviously, as shown in the figure, it would be the maximum positive and maximum negative value of each of the internal forces, the axial, shear in Y, shear in Z, moment about X, Y, and Z, which altogether would give us 12 critical load cases. And then it checks for the combined resultants, which is maximum shear, maximum bending, and combined normal effects. It also evaluates cases where the shear and torsion acts together, because torsion can significantly change the shear behavior. And finally, it looks at the worst edge stress in the cross section as well, because in certain cases that's often what's governing. Now, this is the logic behind the selection of the load case. Now that we have seen the logic, let's discuss about the calculate load extreme option in Idea Statica. Now, many of you might have noticed this option, which is the calculation of load extreme. So what happens in there when we enable that in a connection group? checkboard scans all load combinations for all connections in that group, and it automatically keeps only the extreme, the governing load effects, and unselects the rest of it. So instead of checking hundreds of combinations per connection repeatedly, we reduce it to only one or a few of the critical ones. So that's why in most of the cases you might see a different number of critical load effects as per connection. Sometimes it could be 2, it could be 1, it could be 3, etc. So in those cases, if you want to create, or if you want to know how to change the typology, if you would want to change the typology or the operations based on the envelope, then you can change that as well. Now, after loads, then it would be the batch design or the batch analysis. A few terms that you would want to know before we proceed with the demo, which would be the reference connection. Now, what is a reference connection? It is the master connection for which we would be modeling the connection components in Idea Statica application. There are child connections. They are within the same family, but they are automatically linked to the reference connection. Now, there is one click batch run, which is the calculate all tab or calculate group tab, which means that checkboard runs every child in that group, including the reference connection, in just one go. And also, we would be able to see the progress of the design, if it has passed the code check or if it has failed the code check, by seeing the color coding within the checkboard, and also by watching the symbols next to the respective connections, which would be a green check, a red cross, a cogwheel with a proceed mark, which Venki would be explaining much in the demo session. And okay, now the question that you would have in your mind is, what is the difference, or what gets copied from the reference to the child, and what stays unique in each of the individual connection? Obviously, the copy from the reference connection would be operations, the parameters, if you have defined any, the design codes, and also the settings, and also the report templates. But what stays unique per connection would be the internal forces or the load effects per connection, the member sizes, orientation, and also the member local accesses, and the utilization for individual connections. That stays completely unique, irrespective of what the reference and which the child connections are. Now, about the reports, the generation of reports in Idea Statica, you can generate a bulk report or generate the binder completely after the first iteration, or after revisions, or after the consultant comments. All you have to do, if at all there is a revision, is that just go back to the design, do the changes that you want to change, do the bulk analysis again, and then come back to the report. Just click on the generate option. It would automatically regenerate, and without changing the customization that you have kept for the project initially. And also, the best part is that it can be exported not just as a complete binder, but if you'd want to export it for individual connections, then you can do that as well. Now, don't as in the beginning, as I've mentioned, not just the PDFs, but also the design transfer, the intent transfer, as 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 whole as it is, without losing anything, as whole as it is, by two methods, which is IFC, and also as viewer, which is the Idea Statica viewer. And with that, I am passing the presenter on to Venki. So Venki, just walk us through the demonstration of the checkboard.
Yes, thank you, Rose. Thank you for walking us through the technical aspects of the patch workflow, which users get benefited from. Let me quickly share my screen to walk you through the uh, practical application side. So I hope everyone can see my screen. Okay, great. Thanks for confirmation. So let's walk through the demonstration. So in the checkbot, once you have the model integrated and imported into checkbot, this is how it looks like, the entire structure, which has all the information about section sizes, material grades, so on, etc. To quickly see that, you can go to the material tab, and here you can see all the cross sections and material grades which were imported from the global analysis model. And all the load cases and load combinations which were there in the global analysis model will be imported as well, which can be found in the loads tab. Left side, you can see all the load cases and load combinations, and right side, you can see the result class for which your respective connections are being analyzed for. So it is very easy to customize this. You can just right click and delete it, or just drag and drop the load cases for the consideration, or create your own result class if you want to analyze certain sets of connections with a particular result class. And also, you have the conversion tab, in which some of the material names in your global model might not exactly match with Idea Statica database names. That list will be here. So as you can see, you can just click on this plus to create, to assign the Idea Statica native database profiles into this unmapped section sizes if it was not mapped properly. And this can be done at any point of time in the process. So if something is done accidentally, you don't have to worry about. And this is what we call like dynamic transforming cube. As of now, it is transparent, but I call it dynamic because it changes colors based on the status of the connection, which Rose explained. And this cube is unique to each location, which has a unique name. This connection name is 38, which can be seen on the right side. And also we can see the rafter is split. This is very common in the global analysis model, but we do not want this for the connection design. So what do? There is an option in checkboard like to merge the member. Just click on the member, and in the top structural model options, there is a merge option. Just click on it. It will give you a list of the members which can be merged. Just switch it on and click on merge. Press OK. And similarly, you can repeat the process for the left side rafter. Just click on one member and merge. It will give you a list of members that can be merged in the same plane. So merge it. And one shortcut in this is like, similarly, just click on the merge. If you have automatic tick at the bottom, then click on the top to auto select everything and click on merge. Similarly, like if you have the selected member at the top, then select the bottom member to auto select all the rest of the members in the selection. So that is a shortcut if you have more members. And similarly, you can repeat the process for the rest of the rafters, like third rafter, merge, fourth rafter, and the last rafter. Yeah, so the merging process is done. And you can see the group one, which is corresponding to a single group of set of similar connections. And the highlighted locations were on the canvas, yellow color cubes. And at any point of time, if you don't like the name assigned by checkboard, you can change it to your preference or what you want to assign to that particular group. Like here, I will change it to base plate connection. And it will be changed. The group name will be changed from default to the base plate. And also, this group has one connection with underline, and the rest of the connections without underline, which means the underline connection is the master connection or reference connection, and the rest of the connections are like child connections or dependent connections. So we will work with only the master connection. Let's see how it goes. So we are opening the 23rd connection, and the analysis will be performed in the connection module itself. Checkbot itself doesn't have a native analysis engine. So we are opening the 23 connection in connection module. So here it is. The member topology is there, and all the load cases were automatically imported from global analysis model. All we have to do is like assign the design operations, like the base plate in this case. For that, we can go to the operations and click on the base plate operation. But since we are highlighting about the workflow, let's take shortcut, which can be done, which is possible in Idea Statica. For that, go to the propose option Once you click on the propose, the similar topology will be templates which can be applied to this topology will pop up. Just select as per your requirement and just press OK for automatically assigning the template to the topology. And I have my connection already done. So if I want any changes, then I can quickly change by referring to the properties. I'll quickly save it and I'll close it. So we have done with the master connection or reference connection. If you want to have buckling analysis done as well, so if you click the master connection, there is an option on the right side to switch on the buckling as well. So you can just stick it on only for the master connection, and that setting will be automatically copied to the rest of the connections. And also, if you click the group, then you will see an option called calculate load extremes, which was explained by Rose earlier in her presentation, like what it does. Once you switch it on, the load extremes will be calculated for the similar connections in the group. As of now, here you can see the group has 6 connections, but the critical connections are only 4, which means 2 similar connections does not have any critical load combinations and does not need any analysis. And so after we switched on this calculate load extremes, let's see how it works. So 23 connection is not a critical connection as per critical load effects. So if we open the connection in the connection module, let me just see it in the connection module. Here it is. So all the load effects here on the right side are switched off, which means no load combination is critical. That's why all the load combinations are switched off. And also you can see a dash next to 23, which means it is not critical and no need of analysis, which was decided by critical load effects. Let's open other connection, which is a 34 connection, and see what happens there. So here you can see the load effects. All the load effects are switched off and only certain cases were switched on, and it is disabled mode, which means the critical load effects alone are chosen. This is automatically done by the checkbot itself. So this is what critical load effects does. If you have huge number of load combinations, it will reduce it to manageable, minimal set of load combinations for faster analysis and to save a lot of time. And also left side, we can see the design operations are getting automatically copied or automatically propagated from the master connection into this child connection. So let's just close it and click on the connection, right click on it to calculate all. So with one click, we can calculate all the similar connections in that group. So we can see 2 dots next to 23 and 27, which means a dash, which means those 2 connections are not critical. And in the right side as well, we can see that calculate load extremes. Only 4 connections are critical. So only those 4 critical connections are being analyzed. And once you click the analyzed connection, you can see the summary of results, plates, anchors, wells, including buckling. So while the analysis is performed, you can check the results without opening the connection module again. And similarly for the next group, we will open the master connection and just click on 6 and open the master connection. So here we can see that it is saying the saving connection. In checkbot, there is no automatic save button, but the saving is done automatically. So you don't have to do anything. This process is automatic. Now, after saving, the 6th connection is getting opened. And similarly, what we done in the first group, we will repeat the same process again. We'll assign design operations and we'll switch on the calculate load extremes and buckling, and we'll calculate all. And similarly, we'll repeat this process for the few other groups. Like group 11, we'll open the master connection. It saves the checkboard file, and it opens the 50 connection in the connection module. and we will bulk calculate. So what we are doing is we are analyzing each and every joint in the structure for their respective load combinations, which will end up having economical design than having like over conservative with more thicker plates or more bolts, so on, etc. So we do have a lot of shortcuts to use in ID Statica. So if you're not using them, feel free to explore them. So the group 2 is done. Then we'll go with the group 3. Group 3 will open the master connection, which is connection 25. And we'll assign some template. We'll save it, close it, and analyze it. And group 6 is the last group we will be analyzing for this demonstration. So here also we will be opening the master connection and assigning a template, and we will be bulk analyzing. As you can see, there are 16 critical connections in this group 6. So this is a common like a structure in any of the moderate to big scale structures. Like as Jan mentioned at the start, data centers will have a lot of repeatable connections, and these warehouses or decking slabs or floor mezzanine floors, so on, etc. All this will have a huge number of repeatable connections. So we will design one and bulk analyze the rest of the similar connections in this fashion. So this 6th group is almost done. So it is done. You can see the dynamic cube transformed into green, which says code check passed. So after we have successfully analyzed, the next step is for us to prepare the report. So let's go to the report tab. And the report tab here is not an individual report. It's a submission ready binder, what you'll get out of it. So ID Statica reports are flexible, as you know. So you can select any options you want to see, like the project info, software information, and the connection settings. And you can switch off, switch on any report you want to see in the binder. And certain reports as well, you can switch on, switch off. And also, there is a user paragraph for the project as well, in which you can add certain text or any visuals. So here I'm adding a visual for the entire structure. So as you can see, this image, I can see it in the final report, as well as individual groups as well. You have this option to add any custom defined paragraphs or the images. You can just type anything, and or you can just add an image. The purpose of adding an image to a group might be similar to represent the marking plan for that respective connection. And similarly, we'll repeat the same process for the rest of the group. Like group 2, group 3, marking plan for next group, and for group 6, and finally the group 11. So once it is done, we will click on the generate. In report, we have 3 sets of options. First one is a brief, the second one is a 1 page, and the last one is a detailed option. Which we are generating is the detailed option, which has the summary and the individual reports which you extract from ID Statica attached. And you can see the middle table which says generating report 33 of 53, which means entirely 53 connections are selected, and report has been generated like 41 of 53, and those are getting attached. So it will take hardly like 1 to 2 minutes to generate this, but it is better than spending hours or even days just to do the admin work or the documentation work. So here is the report. First is the project information. You can customize it as per your requirement. And next is the structure representation for which this particular package is being submitted. And followed by the software information, followed by the summary of all the connections which we selected, of all the groups, followed by connection IDs and the status and the percentage. So if you select the brief option, you will have till the summary of it. But since we selected detail, we can have the continuation with base rate group, which has the marking plan, followed by the individual reports, like the project item 34. This is similar to what we extract as an individual report. Like it has all the information about the inputs and the stress checks, strain checks, and even buckling analysis results, and followed by the second connection, and so on, etc. And also right side, you can use these connections as a bookmarks as well. Just click on it to just go to that location. Like group 2, you can see the group 2 marking plan, and fifth connection, group 3 marking plan, and group 4, 9 connection, group 6, and so on, and so on. So this is very easy to review whether everything is okay or not. And finally, you can export the combined binder, and this report can be exported as a two formats. One is a document and the other one is a PDF file. So you don't have to do anything. You just print it and submit it. And once the report is done, along with the report, we also have to transfer the design intent. For that, checkboard helps you in a couple of ways. First one, for the connections which we need to transfer the information related to the design intent, we'll just select the connections on the tree of items which we see here. Like I'm selecting the groups. We are seeing in the canvas the IDs selecting, which are the cubes, and just click on the viewer at the export connection, which will create a new cloud link, which can be opened in any browser. You don't need ID static applications for it. So here you can see the viewer link, which has the information about section sizes, load effects, the plate bill of material information, this very detailed information, and the well sizes, the type of wells, anchor dias, and even the concrete block information. And this viewer link has not only a single file, but all the files what we selected in the checkboard. And also you can select any connection to see it. Like you can also see the detail level of information available in the viewer. And this viewer link can be downloaded as a 3D DWG file. You can export as ID statica file or export even as an IFC file. Easy to share. And second method is we will select the connections, what we want to export, and go to the export connections, click on IFC. There are two options, multiple IFC files or combined IFC. So we'll go with combined IFC for this and just save it with some name. Here we'll go with the warehouse IFC. And one IFC file will be opened. So here it is. So as you know, the IFC files are the most compatible formats throughout any of the BIM models or FEM models or CAD models. So this IFC model has a lot of data as well. Once you click on it, you can see the information about each object, about the anchors, M24, so on, etc. And the most of all, the major benefit of using this IFC files is it retains the coordinates so that you can superimpose with any of your third-party applications to check for any clashes with other departments. So that is the end of the demonstration. Let me continue with some of the tips you can use while working with the checkboard. The first one is the force check. When you import your global analysis model into the checkboard, you might be curious to check whether the forces are exactly transferring as per the global analysis model or it is not. So then you can just open the model in the checkboard and go to the draw option. and select any degree of freedom, like any translational or rotational, to see that respective view while selecting the connection IDs in this tree of item. So in this case, I selected the connections and I selected the major axis bending moment diagram, and I can see the view of it accordingly. So this serves a purpose like to quickly verify whether the forces are being transferred properly or not. So use this option to cross check the forces properly. And the second one, area selection tool. The sometimes the global analysis model will not properly match with the checkboard. We might have to assign some eccentricities as per the connection intent. So checkboard has unique options. For that, you can just click on the member to assign the eccentricities of this member at the start node and end node, and this object or this member will be offsetted accordingly based on the eccentricities provided. And if it is a big structure, there might be a lot of members. In such a case, there is other option which is called area tool. You can just select the area tool and select all the members by a drop box in the area, and you can assign the eccentricities for all the selected members in one go. And also all the selected members can be adjusted with respect to the insertion point, like top of steel or bottom of steel or CG to CG, so on, etc. To have more context on this insertion point, you can see them here. Like if you put top, all objects will be aligned with the top, and if you put bottom, all objects will be aligned with the bottom. And you can select any of these options in the insertion point. And the result class, which we have covered briefly in the demo, but the main use for this is like if you have a certain connection group which is to be analyzed for only a certain set of load combinations. Like for example, we will assign sometimes overstrength factors for the global analysis model, which might not be required for regular connections. In such a case, you can choose to not select that overstrength factors load combinations and select only regular load combinations and create a new result class with this clicking on plus. And you can click the master connection in the group and assign the result class as a newly created result class, so that this group will be checked for the new result class of load combinations which you have created. So this is very flexible. And the next one, this one also we have covered in the demo. You can select the members to merge as per the design intent. Global analysis, you have to split the member in order to assign a node. Typically, the workflow instead, you have to split the member in order to assign a transverse member. Therefore, in the connection design, we don't want split. We want a continuous member from this end to the apex of this rafter. So you can quickly merge by selecting a member and clicking on merge. You will get the members and select it and click on merge, just like how we seen in the previous demo. And final tip is the labels. If you switch on the nodes in the label section, you can see all the labels for the nodes in the structure which was imported. And if you click on members, you can see all the member IDs. So what is the benefit of these two is you can correlate the checkboard model with your global analysis model with reference to these member IDs and node IDs. So the node IDs and member IDs remain same in your global model or the checkboard, so that you can quickly check the forces at that particular node point or the cross section of that particular member size, a quick verification. And in addition to this, there is a connection label which is unique to checkboard. This is created by checkboard automatically, and each of this label, you can see it in the right side in this tree of items. All these are labeled here. So use case might be like you can keep this as a reference marking plan, so that you don't have to like manually mark everywhere. You can just take a screenshot and share it with your detailers. I mean, that is one way. There are other ways as well. And finally, the group labels. So each node assigned to which group, that is a label, which might be useful to identify the similar connections. Like for example, group 4 is one connection, so which was quickly marked here. So use all these steps, use to have smart workflows to reduce your manual effort. So that's it from me. I would like to pass the word back to Jan.
Thank you, Enki. Wonderful presentation. Now let's hear from our audience through second poll that I'm launching right now. Okay, so it's on. Please go to the poll tab and vote in the second poll. How did you perceive what you've heard and see today would improve your workflow? Either it would be a major change, it would be great change, it'll be somewhere in the middle, you would use it once in a while, depending on the project. You're not sure, you will need to test it, or you just work completely differently, or you don't believe that it would help you. The same applies if you already use Idea Statica and you either partially or fully implemented this process. Let us know how much did it influence, much did it change your workflow. All right, the votes are coming. Still a lot of people didn't vote, but we can wrap it up in a few seconds. So far, very useful, very useful. Clear productivity gain, which is a great sign of how significant this topic is. And basically, if you haven't explored this so far, reach out to us, and we are here to support you. All right. Before we wrap the session up, what should be the next step? Whether, again, you are a user of Idea Statica or not, the first step is always the technology. So I would like to quickly review what options do you have in terms of Idea Statica, because as you could see, Idea Statica would be the tool to connect with your global analysis, connect with your CAD solution, CAD modelers, to really streamline the data flow into what we like to say, one beautiful BIM that works for steel structural engineers. So Idea Statica has two main options for the licenses. One are standard group, the other is enterprise. The whole logic is based on the best fit. So if you're a small company, individual, 2-3 people, the standard license would be very good fit for you. Typically, when you're of a bigger size office, you want to have a license with multiple seats. You sometimes want to share the license with multiple offices within the group, sometimes even within multiple countries. Typically, your EPC, your consultant, contractor, steel fabricator, the enterprise license would be the best fit. Why? The use cases. You can see that in a standard, it's strictly divided based on the specific project that the company typically does to what use cases you can do with Idea Statica. If you remember the slide at the beginning, 5 use cases where Idea Statica helps: standard connections, complex anchoring, critical member, concrete discontinuities. You can choose the license that specifically fit just your use cases, just your projects. In enterprise, you don't need to care. You have the highest configuration, highest coverage of the use cases. Next, extra apps and extra add-ons. This is what our team, GSD Idea, delivers to enterprise customers on top of Idea Statica. Based on the experience with EPC companies, contractors, consultants, we developed and designed applications that help you on the data streamlining journey. So it's an extra additional value that saves you more time. And honestly, it's not just you, it's all the related roles around. The next would be the consulting. Having the technology is just the first part, but utilizing it properly typically requires a face-to-face meeting, implementation, guidance, parametric template setup, sometimes even automation scenarios. So with enterprise, there are already services included in the package, while in the standard, you're either on your own or you have to procure them separately. The technical support, great on all levels. With enterprise, you get priority. In terms of you really want to plan your costs of Idea Statica, for the standards, it's pretty straightforward. The license, every additional seat that you add to the license, same costs, not really much of a dynamic. So this is a pitfall when you really want to grow your user base and you want to have a dynamic pricing for the bigger seat installations. And of course, if you want to fix your pricing for the multiple years, just for the sake of risk management or your company policy, that is also possible with the enterprise. On top of that, few technicalities that are linked to the license scope and compliance. Some of them I already mentioned. Few would be minor limitations as well. Again, standard tailoring, more one-man businesses, small companies, while enterprise, the mid-size, bigger, and enterprises. So the call to action is very straightforward here. If you have Idea Statica license, reach out to us. Leave a comment in the chat. Reach out through our webpage. Send us a mail, call. We will be more than happy to guide you through the proper licensing option for you, whether you have Idea Statica or not. And this brings us to the last slide. In case you liked what we're teaching, what we're promoting, the way how we empower structural engineers, there's more. If you're Idea Statica customer and GSD customer, you can apply for onboarding session. These are the following dates. The first one is actually in 2 hours, and Rose and Vanky will be focusing on a concrete. Specifically, this one will be about anchoring. So in case you struggle with the base plates, with the pedestals, sometimes the base plate is at the edge of the concrete block. You can't really make it bigger. All the chicks are failing. What to do, right? And also, if you're using RAM elements, Hilti Profis, this would be a session to show you the approach of Idea Statica and what else you can squeeze out from this use case. Additional onboardings later on in March. If you want to be always aware of new onboarding dates or the updates from either Idea Statica or GSD Idea here in the Gulf countries, there is a LinkedIn group for all the users. You do not have to be customer. It can be you don't have to be customer just yet. We invite everybody as long as you reside in a GCC, as this indeed is Idea Statica Gulf user group. So that would be it regarding the content we prepared. Thank you very much for being with us. and see you at the next webinar. Goodbye.